Hey, how's it going? Welcome to my Godot behavior tree and navigation tutorial series. After you finish this series, you'll have something that looks like this. So a pretty simple seek and wander behavior. If the zombie doesn't have line of sight to the player, it'll just be wandering around and pausing for a little bit. But if the zombie has line of sight to the player, it'll try to navigate to the player positions. And if the player manages to break line of sight again, then the zombie will go back to a wander behavior. So that's the project. Let's jump in. Okay, so the first thing we need to do is create a new project. So just open up your Godot engine and click on new project right here. You can give it a name, whatever you like. I'm going to call it Godot behavior tree u2. And I'm going to give it a path that I have already set here. And just click on create and edit. That will bring you to this page. Well, this scene is just an empty scene, a brand new project, nothing is in here. So let's go ahead and make some new folders. So let's make a folder that's called asset and a folder that's called scripts and a folder that is called scenes. Okay, that will be our very simple project structure for this tutorial. Now let's take a look at some of the project settings. So let's go to project and project settings. The first thing we're going to be looking at is the resolution. So go down here to display, window, and look at the size over here. Let's change this to something a little bit smaller. Let's change this to 640 times 360. But we want to change the test width and the test height to something bigger. So when we're testing, we're not just looking at a super tiny window, even though the resolution is set to a lower resolution. Let's change this to 1280 times 720. And another thing that we need to change is down here, the stretch mode. So when it's disabled, basically when we're testing, we're going to be looking at a wrong resolution. So we want to change this to 2D. And let's just close it. Next, let's get some assets for our game. So let's go to the Kenney asset link that I have in the description, which is the top-down shooter asset pack, and you should see this page. Just click on download and that will download the asset for you. After that's done and you unzip it, you should be able to see something like this. So for our project, we will be using tile sheet complete. So let's just drag this into our asset folder. Oh, well, that didn't work. Let's just drag it in here and go back to the Kenney asset that we just downloaded and go into PNG files. And let's just go to the old min file. So I'm using this file for my player character, but you can pick whichever you like. So let's also drag this into the project and move it again. So there you go. There we have our only two assets that we need for this whole series. Now we can create our player character. Let's just click on 2D scene here to make a 2D scene and add a new kinematic body 2D node. Let's rename this to player, and let's add a collision shape 2D and a sprite 2D. Well, it's just called sprite. Okay, so you can see that there's a tiny warning icon here. It's because we don't have a shape specified. So we're going to need to add a shape over here. Let's just use a circle shape and just like that. For our character, we're gonna be using the old man with machine gun. So just go to your asset and drag this into the texture. So as you can see, the collision, this sphere collision is a little bit smaller than the player. So we can change that over here. If you click on the circle shape over here, it will open up these properties for you, so you can change the radius and some other properties. Let's just change this to 24. So that's good enough. That kind of represents the player collision pretty well. So let's just leave it at 24 for now. And as you can probably see, the player texture is a little bit blurry. That's because when we imported it, we didn't set it to use the pixel art preset. So for this project, we're not going to be focusing on how it looks, but if you want, you can also come in here. You can just go in here and click on your texture and click on import. And you can see here we have import as like bitmap, image, texture 3D, a bunch of stuff. We're going to import as texture, but we're going to choose a 2D pixel preset. And if you click on re-import right now, you can see that the texture has become much sharper. And you can do the same for the tile sheet. So let's just do that. Click on 2D pixel, click on re-import, and actually you can just click on 2D pixel and use set as default for texture. So everything after you set this up, all of the textures that you imported, they'll just be imported with the 2D pixel art preset. So depending on your project, you might want that. Okay, now let's create a new script for our player character. Click on player and click on attach script. And we're going to be making a new player.gd script. Let's move this into our scripts file, scripts folder. Click on create, and that'll create our new script project for us. Also, now we can also save, just Control S and save this scenes. Let's go into our scenes folder and let's just call this our main scene. And click on save. Okay, before we start making our player script and controlling our player, let's just go into our project settings one more time. And let's go to input map section. As you can see, there are a lot of actions already mapped here. You can just use these like UI up, UI down, and just add in the keys that you want to use. That's totally fine. But in this tutorial, I'll be adding some more mapping here. So I'm going to be adding move up, move down, move right, and move left. So yeah, you can just type and click on enter and that'll just add it in there. And we're gonna add in those keys for our newly created actions. Let's just click on add key here and press a key. Let's give it W. And for move down, let's give it S. For move right, let's give it D. And move left, just give it A. Okay, so that's done. That's how you can add in new mappings for different actions that you want for your characters. Very simple. Now we can start working on our player functionality. So let's just go over here and click on the script icon to open the player script. So usually the first thing I would do after creating a new class is just giving it a class name. So here we can just call it player. That'll make sense. So by doing this, you can easily you'll be able to do type checks against the objects that you pass in somewhere else and make sure that if it's to check if it's a player class or not. And also I think overall it's just a good habit to have to give all of your classes a self-explanatory name so that everything is as clear as possible. Now let's move on to our player movement. So we're not going to be doing that inside the process function, but instead we'll use physics process. So the physics process function is synced to the physics step of the engine, so the delta time will always be the same. It will just be fixed depending on the physics frame rate. So that would be great for making our movement code here. So the first thing we're going to do is we're going to try to get our input vector from our input. So that would be our WASD key that we just set with a move up, down, left, right action. So we'll just give it, initialize this to a 0 vector, and let's work on our input vector dot x. That should be input dot get action strength. And you can see that Godot is really nice. It already provides us with the list of the actions that we have. So for our x-axis, we're going to be using move right minus input.get action strength move left. And for our input vector dot y-axis, so what I did there was just Control D, and that would just copy the line into a new line. Very handy. And for our y-axis of the input vector, it's going to be move down minus move up. So if you're a little bit confused right here as to why it's move down minus move up instead of the other way, so inside Godot, when you're looking at a 2D coordinate system, it looks like this. The x-axis goes to the right and the y-axis goes downward. I should probably put this here, x and y. So we're pressing WASD. When you're going down by pressing S, you want the strength to be 1. And when you're pressing W, you want the y-axis to be -1. And when you're pressing D, you want the x-axis to be 1. And we're pressing A, you want it to be -1. Okay, so that's the Godot 2D coordinate system. Now that we have our input vector, what we will want to do is normalize it. So we call the input vector dot now equals to input vector dot normalize. So what this does is just normalize the vector length or magnitude to 1, because if we don't do that, we might get some issues. Like, let's go back to our drawings here. Let's say we have our input vector today as 1 and 0, so we're pressing down D right now. So that's all good because the vector length is exactly 1, and after normalizing it, it doesn't change. But let's say today we're pressing D and S at the same time, so we will get this vector right here, which is 1 and 1. So if we just directly use this without normalizing it, you can see the vector length over here is larger than the length over here. So that means when we're pressing both D and S down at the same time, the character can actually move faster than usual. So we will want to normalize the length of this vector to be 1. So we normalize it, and that will basically just shrink it down to somewhere around here. So it will be this vector over here. So that's basically, if you draw a circle on this picture that has 1 radius, that means normalizing will just put all the vectors onto that circle. So let's go back to our code, and now that we have our normalized input vector, we can use this to set the velocity for our player character. But before doing that, let's come over here and let's make a new variable called max speed, and let's give it something like 5. And we're actually going to add a export keyword here. So this means once a variable is exported, we don't have to change the values in here. We can actually, if we go back to player, you can see that there's a script variables field over here that is just max speed, and we can change it here and play test it, and if we don't like it, we can change it to something else, and basically just helps with our iteration time. So let's go back to our player class, and let's use our input vector times max speed, and we're going to assign that to our velocity. But we don't currently have a velocity member variable, so let's also add that here. Variable velocity, and yeah. So now that we have our velocity, we can use a function called move and collide and pass in our velocity. So this is a function from our kinematic body 2D. So basically this will move the character with a given velocity, and if it collides with anything, the physics system will try to resolve that. So let's see how this turns out. Oh, and it might ask you to select a main scene, so just go ahead and do that. We can just pick main, and you can see that the character is moving. Yeah, so if you don't like the speed, you can just go ahead and change it in the script or just on the character and try to find a sweet spot for that. Like if you change it to 10 maybe, it'll go 2 times faster. Now, even though we got our character moving, we actually have a bug in our code. So let's go over here and let's take a look at move and collide function. You can click on search help and search for kinematic and click on kinematic body 2D and just search for move and collide. So you can click on over here and you can see the documentations on all the functions in here. This is really handy if you're ever confused about some of the functions or some member variables. Definitely just click on search help or go to the online documents and look at them. So you can see over here, move and collide, it actually takes in a relative vector, while move and slide takes in a linear velocity. So what this means is we pass in our velocity over here, but actually we need to multiply our velocity by the delta time. Okay, and if you look over here, move and collide actually also returns a kinematic collision 2D. So if you ever want to look at what your character collide with, this will return you the collision information for that movement. So let's go back here to our player code. Let's put our delta time here, and let's try that again. As you can see, the character is moving extremely low right now because the delta time is super small, around like 0.016. So we would need to bump up our speed over here. We're gonna change that to something like 200, and let's give that a try. Yeah, so this is a lot better. So this is probably the speed that you might want. You can tune it to a little bit higher or lower to your liking. But now that we have our delta time over here, this should be good for now. But right now our character just moves around and doesn't rotate, so that looks kind of weird. So we can go ahead and add that in. Let's just create a new variable called rotation radian, and this will be arctangent 2. We're going to be using this, and I'll explain that why a little bit later on. So let's put in input vector dot y and input vector dot x. Okay, so now if you go to the online document and let's search for arctangent, and you'll see arctangent over here, and there's also arctangent 2. So let's click on that, and you can see the documents here. So arctangent is just returning the arctangent of s in radians. use it to get this the angle from an angle's tangent in trigonometry. So the most important part here is this method cannot know in which quadrant the angle should fall. So we will want to use arctangent 2 if we have both y and x, so we can get the correct angle, basically. So we use arctangent 2 and we give it the y value and the x value, and this will take into account the sign of both arguments in order to determine the quadrant. Okay, so by using this, we would get the rotation radian for our character according to our velocity. So if we right now use the rotation radian to set the rotation for the character, let's give it rotation radian, and by doing this, the character should be facing its velocity. Let's give that a try. Moving around, and as you can see, yes, the character is facing the direction that it's going. So the last thing we want to do here is really simple. So let's go back to our script and let's edit check before normalizing our input vector. So we only do that and also setting the velocity when the input vector is not 0. So if input vector is not vector 2.0, so only when we have values for our x-axis and y-axis, so when we're pressing down buttons, only when that is true that we'll want to set up the velocity and rotation for the character. If not, we can just set the velocity to 0, vector 2.0. So that will be the last thing that we're doing here. So that's it for this video. If you enjoyed it, please leave a like, comment, and subscribe. I really appreciate it. I also just want to talk about what this channel is and what my plan for the futures are. So this series is actually the first organized video series of this channel. As you can probably see, this channel is currently filled with a lot of random stuff that I uploaded throughout the past years, but for the foreseeable future, I'm going to be focusing on Godot engine and AI related tutorials and stuff. So if you have any ideas, please don't hesitate to leave a comment, and I'll see you guys in the next one.